Hey everyone, and welcome back to The Quick Curio. Ever found yourself staring up at the night sky, full of questions? You're in the right place. Because today, we're diving into some of the most fascinating mysteries of our universe. Let's start with something truly spectacular. A blood moon. Have you ever seen the moon turn a spooky, deep red during a lunar eclipse and wondered why? It's not a sign of the apocalypse. I promise. It's actually a beautiful atmospheric phenomenon. During a total lunar eclipse, the Earth positions itself directly between the sun and the moon, casting a shadow on the lunar surface. But some sunlight still manages to sneak through Earth's atmosphere. Think of it like this. Our atmosphere acts like a giant filter. It scatters the shorter, blue wavelengths of light, but allows the longer, red wavelengths to pass through. This reddish light is then bent, or refracted, towards the moon, painting it in that stunning, coppery red hue. It's basically all the sunrises and sunsets of Earth projected onto the moon at once. How cool is that? From one celestial body to another, let's talk about a real fan favorite that got a controversial Remember the mnemonic, "My very educated mother just served us 9 pizzas"? Well, these days, she's only serving 8. What happened to Pluto? Why isn't it a planet anymore? Back in 2006, the International Astronomical Union, which is basically the official naming committee for celestial objects, redefined what it means to be a planet. They came up with 3 main criteria. First, it must orbit the sun. Pluto checks that box. Second, it must be massive enough for its own gravity to pull it into a nearly round or spherical shape. Pluto passes that test too! But the third rule is where Pluto stumbles. A planet must have cleared its neighborhood, meaning its gravitational force is dominant, and it has swept up or flung away other large objects in its orbital path. Pluto, unfortunately, shares its orbital neighborhood with other icy bodies in a region called the Kuiper Belt, some of which are comparable in size. So, because it hasn't cleared its path, Pluto was reclassified as a dwarf planet. It's still a fascinating and complex world, just in a different category. Sorry, Pluto. Now, let us journey from the edge of our solar system to Objetos. So dense and mysterious, they challenge our understanding of physics itself. I'm talking about black holes. What exactly are they? Imagine an object with such an incredibly strong gravitational pull that nothing, not even light, can escape it. That's a black hole! They are born from the remnants of massive stars that have died in a spectacular explosion called a supernova. After the explosion, if the remaining core is massive enough, gravity crushes it down into an infinitely small point called a singularity. The boundary around this singularity is called the event horizon. It's the point of no return. Once you cross it, there's no coming back. While we can't see black holes directly because they don't emit light, we can detect them by observing their effects on nearby stars and gas. They warp space and time around them, causing nearby objects to orbit in strange ways. And as matter gets pulled in, it heats up and releases X-rays that our telescopes can see. They are true cosmic monsters, but also key to understanding the universe. From the cosmic and untouchable. Let's bring it back down to Earth. We've all seen fiery lava flows in movies or documentaries spewing from volcanoes. It's hot, molten rock. So, could you, in theory, make your own lava? The answer is yes. You absolutely can. Lava is just rock that has been heated to its melting point. Different types of rocks melt at different temperatures, but generally, you're looking at temperatures between about 1,300 to 2,400 degrees Fahrenheit, or 700 to 1,300 degrees Celsius. To do this, you'd need a very powerful furnace, like an industrial crucible or a scientific-grade induction furnace. You could take a common rock, like basalt or granite, put it in the furnace, and crank up the heat. Eventually, it would melt and glow, turning into a man-made version of magma. If you poured it out, it would become lava. Of course, this is extremely dangerous and requires specialized equipment, so please, do not try this at home. But scientifically, it's totally possible. Alright? Let's look up at the night sky again. You see a flash of light streak across the darkness. A shooting star! People make wishes on them. But have you ever wondered if one has actually hit a person? Shooting stars or meteors are tiny bits of rock or dust from space that burn up as they enter Earth's atmosphere. Most are no bigger than a grain of sand. The larger ones that survive the journey and hit the ground are called meteorites. The odds of being hit by one are incredibly small, astronomically small. In fact, but it has happened. The only officially confirmed case is that of an Hodges in Alabama back in 1954. A grapefruit-sized meteor, about 8.5 pounds, crashed through her roof, bounced off a radio, and hit her on the hip while she was napping on her couch. It left a huge, dark bruise. But she survived and became an instant celebrity. So, while you're more likely to be struck by lightning, it's not entirely impossible to be struck by a piece of outer space. Finally, let's tackle one of the biggest questions of all. We've talked about planets, stars, and rocks from space. But what about our own home? How old is the Earth? This question has puzzled scientists and philosophers for centuries. Today, we have a pretty precise answer thanks to a technique called radiometric dating. Scientists study rocks, not just from Earth, but also meteorites that have fallen to our planet. These meteorites are like time capsules, formed at the same time as the Earth and the rest of our solar system. By measuring the decay of radioactive isotopes within these rocks, specifically the decay of elements like uranium into lead, scientists can calculate their age. This method is incredibly reliable. Based on the oldest rocks and meteorites found, scientists have concluded that the Earth is approximately 4.54 billion years old, give or take about 50 million years. It's a number so vast, it's hard to wrap your head around, but it gives you a sense of the incredible, deep time our planet has experienced. And that's a wrap on our cosmic journey for today. From blood moons to the age of our planet, the universe is filled with endless wonders. I hope you learned something new and feel a little more connected to the cosmos. If you enjoyed this video and want to keep exploring these amazing topics with us, please hit that like button and don't forget to subscribe and turn on notifications so you won't miss our next adventure. Thanks so much for watching, and as always, keep looking up.